Morning learners. I'm Mr. Sisho, a technical maths educator. Today we'll be dealing with complex numbers. As you know, it's the first topic, paper 1 of technical maths. Complex numbers. As you know, we started with complex numbers from grade 10. When we started in grade 10, we started with the real numbers and non-real numbers, and the complex numbers come from the non-real numbers. As you understand that if we have the square root of -1, according to mathematics and mathematical literacy, they usually say this is undefined or non-real number. So in other words, we have numbers like the square root of -4, which will be the same answer in mathematics and mathematical literacy. But as you understand that in technical maths, we are dealing with this. We understand that if we have the square root of -1 is equivalent or is equal to I. So in that case, if we have the square root of -4, this is simply the same as having the square root of -1 multiplied by 4. That will be the same as the square root of I squared multiplied by 4. That will give us 2i. So saying this, in technical maths, we have the answer for the negative of a square root, always, because it's a complex number, it's a imaginary number. Now when we move, we understand that we have the real numbers, we have the non-real numbers, and under non-real numbers we have what we call the imaginary numbers, as we said here. The complex number is given by A plus BI, whereby we know this is a real number. Real numbers, we did them from grade 1, and then this is what we call the imaginary numbers. So let us simplify certain things that will help us look at this. Let's say, for argument's sake, we have example 1. Simplify the following. 1.1, we have I to the power of 4. 1.2, we have I to the power of 11. Now when we simplify this using what we know here, that the square root of -1 is equal to I, which is similarly going to say I squared is equals to how much? To -1. If you understand that, if I square this, I'll be left with -1. If I square this, it will be I squared. So similarly, the square root of I of -1 is equals to I, and the square root of I squared is equals to -1. So when we simplify this kind of questions, we use the same method, saying, okay, we understand that I squared is equal to -1. So we'll just say, for 1.1, we work with I squared, because we know I squared is equal to -1, so we are always going to work with I squared. But we have I to the power of 4, so it means it will be I squared to the power of 2. Saying 2 multiplied by 2 is 4. giving us I squared, we know it's equal to minus 1. So we are going to substitute minus 1 here to give us minus 1 to the power of 2. Now anything to the power of 2 will give you positive. So the answer will be positive 1. Good. So looking at 1.2, remember we have I to the power of 11. So since I said to you, we know this. This is what we know, which is what? Which is I squared is equal to minus 1. So we are going to work with I squared. We are going to say, okay, I squared. We want 11 as an exponent. What number are we going to multiply 2 with to give us 11? We don't have it now. So we are going to multiply it with 5 to get 10. And we multiply with I. Remember, I is to the power of 1. So it will be 10 plus 1 because we multiply. Remember, when you multiply the same basis, you add the exponent loss. So we are going to have minus 1 to the power of 5 multiplied by I. Now, minus 1 to the power of 5 is equals to how much? Is equals to minus 1 multiplied by I. That will give us minus I. That's how we solve this. I can give you a few minutes to solve a few questions here, just like we did. Just like we did. Sorry. Simplify the following. In terms of I. In terms of I. Number 1, we have I to the power of 9. Number 2, we have I to the power of 14. Number 3, we have I to the power of negative 2. We have such numbers, right? 4, we have I to the power of 100. And the last one, we can say I to the power of negative 1. You'll have about 5 minutes to do this so that we can move forward with our presentation. Now, looking at this, we can move over. Now, looking at this, we can just say solutions. Number 1, I don't know if you realize this, but so far we only working with exponents. Yes, we are working with I, which is part of the imaginary numbers, but the key thing here you have to understand is the exponent. Now we understand that I to the power of 9 can be I squared, as we said, multiplied by how much? We cannot multiply any number by 2 to give us 9. So what are we going to do? We are going to get closer to 9. We can say multiply by 4. 2 multiplied by 4 would be 8. Multiply by I plus this 1 will be 9. So we'll have minus 1 to the power of 4 multiplied by I, which will give us 1 multiplied by I, which will be I. That is our solution. And the second one, it will be I to the power of 14. I to the power of 14 will be I squared to the power of 7. 2 multiplied by 7 is 14. So we are going to have minus 1 multiplied by 7. That will be minus 1. So minus 1 to the power of 7, that will be minus 1. Okay. Number 3, sorry about that. Number 3, we are going to have I to the power of negative 2. This is an unusual question. It's an unusual question, but no one said it will never appear. We have I to the power of negative 2. As I said, the key idea here is that we have to focus on the exponents. So we have negative 2 as an exponent. So we understand that, okay, if I have negative 2 as an exponent, I'll say, okay, I squared to the power of minus 1. Remember, minus 1 multiplied by 2, it's minus 2. Good. That will be minus 1 to the power of minus 1. Are we together? Are we together? That will give us minus 1. And number 4, we have what we call I to the power of 100. Remember, I said we mostly deal with I squared. So we multiply it by 50, it gives us 100. That will be minus 1 to the power of 50. That will be, oh, my bad. That will be 1, because this is an even number. Minus 1 to the power of 50 will be 1. Good. The last one, I to the power of minus 1. I to the power of minus 1 will have what? We said we are working with what? I squared. But remember, we have minus 1 here. So what can I multiply with 2 to give me minus 1? Minus 1 over 2, if you agree. That will give me minus 1 to the power of minus 1 over 2. That will be minus I. Sorry, minus I. That will be our solution. Now, moving on. Remember, we said complex numbers is given by Z is equals to A plus BI. This is our complex number. This is our complex numbers. Is given by Z is equals to A plus BI. Now let's add and subtract complex numbers and see what we can have. Remember, if I have something like this, it simply means I can have Z is equals to 2 plus 5I, whereby we know that this is my imaginary part, and this is my real part. Are we together? Now when we add and subtract complex numbers, we can have, remember we have Z is equals to 2 plus 5I. Let's say this is Z1. And we have Z2 minus 3 plus 6i. Z3, it's minus 1, my bad, minus I. Z4, we can say we have 5 minus 2i, to keep things simple. Now the question says, the first question says, add Z1 and Z3. Add Z1 and Z3. Now we have Z1. What is our Z1? Our Z1 is 2 plus 5i. So we are going to have Z1 plus Z3, which will be 2 plus 5i plus, what is our Z3? It will be minus 1 minus I. Addition between the two binomials. Good. So we are going to have 2 minus 1 plus 5i minus I. Remember, we collect the like terms. So we have 2 minus 1, it will be 1. 5i minus I. Remember, these are the like terms. And we have I there, it's 1i. So it will be 5 minus 1. That will give us plus 4i. That will be the addition. Number 2. We can say subtract Z4 from Z2. Mostly this question is the one that confuses many learners. They are saying subtract Z4 from Z2. So it simply means we are going to have Z2 minus Z4. We are subtracting Z4 from Z2. So we'll have Z2, it's minus 3 plus 6i minus Z4, it will be 5 minus 2i. That's what we have. So we are going to have minus 3 minus 5. Remember, we multiply everything by negative inside the bracket. So we are going to have plus 6i plus 2i. Negative by negative is positive. So we are going to have negative 8 plus 8i. That will be our answer. That is all we have to understand about the addition and subtraction of complex numbers. That we have to group them according to the like terms. We add the like terms. And as you can realize, this is our A, this is BI. This is A, this is BI. Still is a complex number. Good. We still have time for 2 activities that we can do ourselves. Let's say exercise 2. Add the following complex numbers. What do we have? We have Z1 is equals to 1 plus I, and Z2 is equals to, what do we have? 3 plus I. Number 2, subtract Z1, which is 1 minus 4i from Z2, which will be 2 plus 5i. No, this one will just say 4 minutes or 3. Remember, we do the same thing as we did there. We can move on. Remember, we had what is it? Add the following complex numbers: Z1, which is 1 plus I, Z2, which is 3 plus I. So we are going to say, number 1, Z1 plus Z2. What is our Z1? It's 1 plus I plus of addition, Z2, 3 plus I. Then we have what? 1 plus 3 plus I plus I. 1 plus 3 is how much? It will be 4 plus 2i. Sorry. That will be our addition. And for number 2, the question said, subtract Z1 from Z2. Remember what we did here. Subtract Z4 from Z2. So it will be what? Z2 minus Z4. So when we subtract Z1 from Z2, it will be Z2 minus Z1, which will be our Z2. It's 2 plus 5i minus 1 minus 4i. Then we are going to have 2 minus 1 plus 5i plus 4i. Remember, we multiply or we distribute the negative inside the bracket. So which will be 2 minus 1 is 1. 5 plus 4i, 5i plus 4i will be 9i. That's what we have under addition and subtraction of complex numbers. And looking at our CAPS document, under complex numbers, it stipulates, define a complex number, which is what we did, given by a plus bi. Learners should know, okay, the conjugate of this. We are getting there to the conjugate. The imaginary number I squared, we did that. How to add, subtract, we did that. Now what we are going to do, we are going to multiply the complex numbers and divide. I'm going to do one activity on multiplication of complex numbers and do one activity on, or 2 activities on division, so that we can have time. Then we can represent the complex number in an agate diagram. It's no problem. So let's move to multiplication. First, multiplication of complex numbers. Keeping in mind the addition or subtraction of complex numbers is the same as when you add the real numbers. You collect the like terms. That is very, very important. And you must understand that whenever you have a negative number, you multiply with everything that is inside the bracket, especially when it says subtract from. You must understand how to write it, because most learners that do that mistake. If they say to you, subtract Z1 from Z2, most learners will write Z1 minus Z2, which is incorrect. So in multiplication is the same as real numbers. Still the same. We'll use the same activities we have. Number one, multiply Z1, which is, we can use this one, 2 plus 5i, and Z2, which is 1 minus 4i. We understand Z1 multiplied by Z2, simple as that, which will be Z1, it is 2 plus 5i multiplied by 1 minus 4i. Remember, these two are binomials. That's why we keep them inside the bracket. It's a binomial. This binomial multiplied by this binomial. FOIL, obviously. We are going to say 2 multiplied by 1. It will be 2. 2 multiplied by negative 4i. It will be negative 8i. 5 multiplied by 1. That will be positive 5i. 5 multiplied by negative 4. In fact, 5i multiplied by negative 4i. That will be negative 20i squared. Good. So we have 2 minus 8i plus 5i. We'll have minus 3i minus 20i squared is equals to how much? I squared is equals to minus 1. Remember, we introduced the complex numbers as we started. So we are going to substitute minus 1 for I squared. Then we're going to have 2 plus 20, because negative 20 multiplied by negative 1 to give us positive 20, minus 3i. Remember, these are the like terms, but these are not. So we'll have 22 minus 3i. These questions, we can rephrase the question by saying, find the product of Z1 and Z2. You must keep in mind that when we say find the product of two numbers, we simply talk of the multiplication of the two. Are we together? Good. So we can simply say, number 2 again, find the product of Z1, which is equivalent to minus 5 plus 2i, and Z2, which will be minus I. Yes, it's a complex number, this one. It's a complex number. So we'll have Z1 multiplied by Z2. And then we're going to do this. Z1, it's minus 5 plus 2i multiplied by Z2. We only have what? The imaginary part, which is minus I. So what will be our real part? it will be 0 minus I. Remember, it's a number. So if it's not written there, it simply means it's there. So we multiply, we're going to say minus 5 multiplied by 0, 0. Okay, can I write it? Okay. Minus 5 multiplied by minus I will have positive 5I. 2I multiplied by 0, it will be 0. 2I multiplied by negative I, it will give us negative 2I squared. Now 0 and 0 is yes. So we have negative 2 into negative 1 plus 5I. Remember, I squared is equivalent to minus 1. That will give us positive 2 plus 5I. That is our final answer. Let's do division. Let's do division. Let's do division, then we'll do activities after division. Now, remember, with division we have division of complex numbers. Okay. Before we can move with division, there's a very important thing that we have to take into consideration. We call it the conjugate of a complex number. This is what our CHEPS document was talking about here. The conjugate of the complex number ZA plus BI. Now, we understand our complex number is equal to A plus BI. Now, what we know as a conjugate, as we talked of, it will be the power of Z is equal to A minus BI. In other words, we change the sign of what? Of our imaginary number for the conjugate. So in other words, if I have example 1, if I have Z is equal to minus 2 minus 3I, our conjugate will be what? Minus 2 plus 3I. That will be our conjugate. If we have number 2, Z is equals to 100. Z is equals to 100. What will be our conjugate? It will be 100. Because we don't have the imaginary part yet 0, so it will still be 0. Good. That is what we have to understand when we talk of conjugate. We only change the sign of the imaginary number or the imaginary part. So, under division, we can say divide the following. Divide the following. We have Z1 divided by Z2, which will be 2 plus 3i divided by 1 plus 2i. Now, when we have to divide this, the most important thing you have to understand is we have to multiply by 1, which is the fraction of the conjugate of the denominator. Now, this is our denominator here. We are going to multiply everything by the conjugate of this denominator. In other words, what I mean is we are going to multiply by what is the conjugate of the denominator. Remember, we change only the sign of the imaginary part. So we are going to multiply by 1 minus 2i divided by 1 minus 2i. When I said we multiply by 1, I meant this. This divided by this is 1, and is the conjugate of the denominator. So we're going to have 2 plus 3i, 1 minus 2i, all over 1 plus 2i, 1 minus 2i. Now, I don't know if you can realize this, but in the numerator there, we have the multiplication of what? Of complex numbers. And again, on the denominator, we have the multiplication of complex numbers. So, we're going to have 2 multiplied by 1 is 2. 2 multiplied by negative 2i will be minus 4i. 3i multiplied by 1, it will be 3i. 3i multiplied by negative 2i, it will be negative 3i multiplied by negative 2i, negative 6i squared, divided by how much? 1 multiplied by 1, 1 multiplied by negative 2i, 2i multiplied by 1, 2i multiplied by negative 2i squared. You work with each step. So I'm going to have 2 minus 6, because I collect the like terms already, because I know I squared is minus 1. Minus 4i plus 3i is minus I. All over 1 minus 4 into minus 1. Now, minus 2i plus 2i is equals to 0. That's what we know. So, negative by negative 6 multiplied by negative 1, it will be positive 6. Plus 2, it will be 8 minus I. All over negative 1 multiplied by negative 4, it will give us positive 4 plus 1 is 5. Then we have 8 over 5 minus 1 over 5i. That is our complex number. Remember, it is A, it is B, I. Again, what is important under division is for you to understand the conjugate. And remember, we said the conjugate of a complex number, you change the sign of the imaginary part. That is very, very important. So if you understand that, you move to division, you are going to multiply by 1, as I said. And that 1 will be the conjugate of the denominator. We can do 2 activities and we'll be done. Just do 2 activities. let me say, simplify the following. Number one, let's say we have, where's those questions? Okay. Let's say we have 2 plus 6i multiplied by minus 3 plus I. Number two, we have, let's have the one of division. That will be minus 2 plus 6i all over 1 plus 2i. Yes, let's simplify this for about 5 minutes or so. Remember, this is multiplication, this is division, for 5 minutes. Okay, then let's just solve these two equations. Then, as we have here the solution. Number one, remember we have 2 plus 6i multiplied by minus 3 plus I. That will give us minus 6 plus 2i. Remember, ladies and gentlemen, when you deal with the binary, the multiplication of, when we deal with the multiplication of complex numbers, it's still the same as when you deal with any binomials. So when I say to you 2 multiply, when I wrote this, in fact, if I writing this, I said 2 multiplied by minus 3 is minus 6. 2 multiplied by I is 2i. So 6 multiplied by minus 3, it will give us what? Minus 18i. 6 multiplied by I, 6i multiplied by I, it will be 6i squared. Minus 6 plus 6 to the power of minus 1. I squared is minus 1. I'll always remind you that. 2i minus 18i, it will be minus 16i. Therefore, we'll have negative 1 multiplied by 6. That will be negative 6, negative 6, negative 6, negative 12, negative 16i. And number 2, remember we have, this is simplified by the way, it's a complex number, we have a plus bi. We have minus 2 plus 6i all over 1 plus 2i. Remember, if I have this is a division. I don't have to be told. I can see I have a complex number divided by a complex number. So this is my denominator. What will be the conjugate of this denominator? The conjugate will be 1 minus 2i. 1 minus 2i. So when I multiply that, I'll have minus 2 plus 6i multiplied by 1 minus 2i all over 1 plus 2i, 1 minus 2i. So we are going to multiply now. It will be minus 2 multiplied by 1, it's minus 2. Minus 2 multiplied by minus 2i, it will give us positive 4i. 6i multiplied by 1, it will be 6i. 6i multiplied by negative 2i, it will give me negative 12i squared, very important, divided by how much? 1 multiplied by 1, 1, 1 multiplied by negative 2i, negative 2i, 2i multiplied by 1, positive 2i, 2i multiplied by negative 2i, it will be minus 4i squared. Then we have negative 2 minus 12 into negative 1, 4i plus 6i, it will be 10i all over 1. Remember, it will be minus 4 into minus 1, minus 2i plus 2i, it will give us, sorry about that, it will give us 0. So we're going to have minus 2, sorry, negative 1 multiplied by negative 12, it will be positive 12, minus 2, it will be 10, plus 10i. Negative 1 multiplied by negative 4, it will be positive 4, plus 1, it's 5. We have 10 over 5 plus 10 over 5i. That's what we have, which will be 2 plus 2i, simplified. Now let's go back. Remember what is very important here, for you to define the binary, the complex numbers as a plus bi. For you, learners should know the conjugate of a plus bi. We said the conjugate of this will be a minus bi. The imaginary number, we manage to add, subtract, divide, and multiply the complex numbers. So all this, we have done it. So I want to thank you for today's lesson. Under complex numbers, we managed to do those things. We only left with a representation of the complex number in an agar diagram and solving equations of two unknowns. Thank you.